Problem number 36. Consider the combustion of acetylene, C2H2, with O2 to form CO2 and H2O. So we're told what the chemicals are that are reacting and which ones are formed. And you're asked to write a balanced equation for this reaction. Molecular art is used to show the molecules of starting material. Fill in the molecules of the products using the balanced equation. So here is the reactant material. We're supposed to draw in the product material. Now, we know what colors atoms we're supposed to be using. So, first of all, let's go ahead and write the chemical equation for the reaction. The chemicals that are reacting together are C2H2, acetylene, and O2. So we put those on the left. C2H2 plus O2. Those react together, and the products are CO2 and H2O, carbon dioxide and water. So those formulas go on the product side, CO2 and H2O. Now, we could add more stuff to this. We could say that this is a gas, this is maybe a gas, and that's a gas, and that's a gas, but we're not really told those details in here, so we'll just leave the phases off for now. But let's balance the equation. So we got three different elements to balance: carbon, hydrogen, oxygen. And since oxygen occurs by itself, we'll save it for last. Why not start with the carbon? We have two carbons on the left, so you have the coefficient 1 here. So 1 times 2, two carbons on the left. And then 1 times 1 is 1 carbon on the right. So we need to bring this up to a 2. And we do that by writing a 2 here. So that affected the carbons and the oxygens, but we haven't addressed oxygens yet, so that's not a problem. Carbons are balanced, so let's balance the hydrogens. We have 1 times 2 is 2 hydrogens on the left. 1 times 2, 2 hydrogens on the right. So hydrogens are already balanced. And now it just remains to balance the oxygens. So we count oxygens on the left. We have 1 times 2 is 2 oxygens on the left. And then 2 times 2 is 4 plus 1. That's 5 oxygens on the right. So we got 2 on the left and 5 on the right. Okay, so let's bring this up to match the 5. And we can say that the coefficient here would be 5 halves. So 5 halves times 2 is 5 on the left. Now this is a balanced equation. Coefficients 1, 5 halves, 2, and 1 does balance the equation. But we need whole numbers, and we got to get rid of this fraction. So if we multiply all of the coefficients by 2, we would get 2, 5, 4, and 2 for the coefficients. So multiplying the 1, the 5 halves, the 2, and the 1 by 2, that's what we get. So we can replace these coefficients up here with the new balanced ones. Let's go ahead and drag these up, and that should balance the equation. So you can check it. So suppose you want to check carbon. 2 times 2 is 4 carbons on the left, and 4 times 1 is 4 carbons on the right. So the carbons balance, the rest of them also balance. Now, the part B to this question, molecular art, we need to draw the molecules on the right. So what does a CO2 molecule look like? And what about an H2O? So a CO2 molecule, you can say the Lewis structure looks like this. You got CO2 CO2. Might take you a little bit of work to figure out the Lewis structure. And here is the Lewis structure for H2O. So water molecules are bent. Remember, here's H2O. Now, it looks like on the left, we have 2 acetylenes and 5 oxygens. That's kind of nice because we have a coefficient of 2 here for the acetylenes and 5 for the oxygens. So what we'll put here is we're going to draw 4 CO2 molecules and 2 water molecules. A CO2 molecule looks like this. You got a carbon and then surrounded by 2 oxygens in a linear fashion. So if I were to draw it, I might draw the carbon like this, and the oxygens, let's see, let me find red. So the oxygen might look like that, something like that. Okay, and we got 4 of those. So let me take this, copy it, and paste here. Well, we got, okay, that's kind of big. So we'll paste that. So paste. Okay, it's going to take more room. So we got 4 of those. Okay, and then what about the waters? We have H2O. Well, the oxygen is the red oxygen atom, and then the hydrogens are white. So just do white like this. This is going to be a bent molecule. Okay, I'm not really drawing these to size. The hydrogens are smaller than the oxygen. So let me take this. And how many waters we got? We got 2 of those. Okay, so 1, 2, and there we go. So if you look over here, you can make sure all the atoms are still there. So you count up the atoms. You got, so look at the oxygens. You got 2, 4, 6, 8, 10 oxygen atoms, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens on the right. And you can check and the other ones are also all there as well. So not only did we draw what type of product molecules there are, we also made sure we had the correct number of them.